Machine learning is a subset of artificial intelligence. It's actually the backbone of it, because without machine learning, the machine can't be smart. So machine learning is a process of teaching a machine to learn from data. Okay? That is similar to how we learn as humans as well. So as humans, we also learn from data. Right now, the data we may see it as information, like the communication that is happening right now through the screen, or communication you have with other people. Wherever you go to and there is information being passed, you're learning. Okay, so just like humans do, we learn from data. Machine learning is the process of teaching the machine how to learn from data. Now, the difference between human intelligence, or human learning rather, and machine learning is in how we learn from data. As humans, we learn from data because we're humans, innit? So we learn from data through communication, like I say. And the communication is from our ecosystem, right? The system or the environment that we're in. It could be from schools, churches, mosques, any learning center. Right? Or it could be from the TV or from your phone. So we learn through interaction and communication, right? Now, machines learn from data. So we pass data to it and it's able to learn from it. Now, machine learning is that process of teaching that machine how to learn from data. All right, so once we're able to teach the machine how to learn from data, then the machine can be smart. It can perform the task like a human would. Okay, so I would go into what is AI and machine learning, how they kind of come together, in using an analogy here, right? Now, if you've been a software engineer, right, or you've worked in the technology space, either building systems, selling systems, or designing systems, AI is also a system. Okay, so now the difference is, because some people would say, and I've had that question, that why do we need AI? We already have systems that perform tasks, which is true. We do have systems that perform tasks. But the difference between a traditional system performing a task and an AI system performing a task is in how the AI system performs our task, right? So in a traditional system, what we would do is we would write our code, and in the code there would be, I'm an AI software engineer, so I will try and go a bit technical, but not too technical, just to explain how we build traditional systems compared to building a machine learning system, or sorry, an AI system. Now, in our traditional system, we would have a lot of conditional statements. If this, then do that. If that, then do this. A lot of conditions to kind of guide the systems to know how to perform that task. With an AI system, we've already trained the machine, so the machine just learns how to do it all by itself. It doesn't need us giving it conditions. It's able to think for itself, mathematically though, but it's able to think for itself and perform that task. Okay, so let me give an example in a workplace. So let's say you're working in a company that you are being bombarded with spam emails, and then your boss says, how do we stop having the spam emails in our email box? With a traditional system, what we would normally do is we will go to a software engineer like myself and then say, can you write a system that filters the spam emails, filters emails coming in, and identify which one is spam and which one isn't spam? Okay, now As a traditional system, what we will do is we will create a pattern saying spam emails contain certain phrases or words, and we will use those words in our conditional statement to say, if the email contains act now, give us your bank details, or something similar, mark it as spam. Else, allow the email to go to the right inbox. Now, what would happen with such a traditional system is the spam email guys will then learn what patterns we're looking for. So they will go, oh, they're looking for words like act now, buy now, bring your bank details. And so they start to change their phrasing in the emails. Then our spam filter starts to fill because now there are new phrasing in that spam emails. Then your boss will then say, bring the software engineer back to adjust this filtering system so it can identify the new spam words or phrases. Now that's a lot of iteration of going back and forth, re-engineering your code and all of that. Okay, and as a business, that's also recurring cost of you constantly needing the software engineer to tweak your spam filter to be able to catch all types of spam. Now, the limitation of that is the software engineer or the software company might just be limited to a certain number of phrases, so they would only be able to protect you from the phrases they know. Now, with artificial intelligence, you can get lots of spam emails from everywhere. So we will feed the machine with a lot of spam emails and a lot of normal emails and send that to the machine to learn from that data. Okay, so we will represent spam emails and normal emails, thousands of them, as data, and then send it to the machine to learn on. Of course, we're using tools to teach the machine. So there are machine learning frameworks that we use, but we're not going. This is a masterclass for beginners, so we won't go too technical. Once you send thousands of this data, both good data and bad data, which is spam emails and non-spam emails, to the machine, what the machine does is it identifies the pattern. It is able by itself, using the tool for learning, so there are tools built for the machine to be able to learn that we use, using the tools for learning to identify the patterns for spam emails and the patterns for non-spam emails. And by itself, without your conditional statements or iteration of maintaining your spam filter, it is able to automatically know which one is spam and which one isn't spam. So that is how AI systems perform tasks. So it does the task in a more effective way and with less iteration with maintaining it. Because once you've trained a model, it is able to see new data and identify new data as good or bad, because it's already encoded in itself the patterns for what is good or what is bad. All right, so that is the difference between a traditional system and an AI system. Now, machine learning is what makes that AI system able to be an AI system, because training that machine, right, on that data for it to be able to create the patterns, and then because it's created those patterns, when new data comes in, it's able to know what is spam and not spam. That is what makes an AI system an AI system. Hope that is clear. So if you see AI as the goal, machine learning is the key tool to get to the goal. All right, so let's see that way. Now, how does machine learning work? Because in this case now, you're beginning to see machine learning as the be all and end all, which it is. Now, we need to understand how AI works. We need to understand how machine learning works. So how does machine learning work? There are three main, I'll call them key ingredients to machine learning. One is data, the second is algorithm, and the third is training. Right? I've used the word teaching a lot. It also means training. So now I'm going to start using a bit technical word, not teaching all the time. Right? So I know I've kind of interchanged it with training, but I try and use teaching more, so you know that it's trying to teach the machine how to learn from data. But in technical terms, that's actually training the machine, right? Now, so the three key ingredients again are data, algorithms, and training. Now, data is the fuel of an AI. Okay, so what is the fuel? When I say fuel, I mean petrol or diesel or gas in your car. The more fuel your car has, the farther it goes, isn't it? Now, it's the same thing for AI. The more data an AI system has, the better it is at performing the task it's been given, because it has a lot of examples to use in making decisions when it has to. So the backbone of an AI system as its fuel or petrol or gas is data. So that's the first key ingredient. The second key ingredient is algorithms. Now, if data is the fuel, algorithm is the brain of AI. Okay. Now, remember I said in teaching the machines how to learn, we use learning tools, right? These tools are the algorithms. It's the algorithms that enables the machine to be able, or system, if that's easier to grab. But I wanted to keep on machine because it's a machine learning ingredient. It's the algorithm that helps the machine to be able to identify patterns in data and relationships between the patterns in the data. So the second key ingredient again is algorithm, and see that as the brain of the AI. Okay, now the third one, which I've labored a lot in this video, is the training, and we call it model training. Okay, now that is the part where the learning process happens. Okay, so it's the part where you apply the algorithm on the data to train the model, right? Because that model becomes, I would say in this case, the core of the AI system. Okay, because the AI system will move on that model. Now, just to give you a quick example, you heard about large language models, right? It's everywhere. They call it LLMs. I've done a technical jargon explaining what that means in another video. Now, large language model is a model that has been trained on data using algorithms that are for natural language processing. So that model is what has been put in ChatGPT that enables it to be able to answer back in natural language, because the data was trained with algorithms for natural language processing. Okay? So those are the three main key ingredients of machine learning. Now, if I want to give an example of how it works, so let's say you want to build a system, an AI system that can identify cats in a lot of pictures. What you will do, right, as an engineer, if you're an engineer, but if you want to know what an engineer would do, what an engineer would do is the engineer will feed lots of cats pictures to the machine. So we get a lot of cats picture. You get grumpy cat, happy cat, Cats are not happy. Moody cat. I don't know. Sleepy cat. Lazy cat. You get all the cat videos or cat pictures and feed thousands of that to a machine using an algorithm for image processing. It's able to create a pattern for cats such that when you give it a picture, it's going to find the relationship between the new pictures pattern and its pattern that it's been trained on, and it's able to tell you this is a cat, this is not a cat. So if you've trained a machine on cat pictures, it is able to identify cats easily within your picture. Hope that is clear. Okay, now this is what happens also. So I'm giving you a practical world examples in fraud detection as well. So when your bank is able to identify a fraudulent activity or transaction, that's because they've trained a model on fraudulent transactions, that when they pass a transaction to it to vet that transaction, it's able to see if the patterns in that transaction is similar to the patterns that it's been trained on. If it is, then it's a fraudulent transaction, and it will flag it as such. Okay.